So we are going to find the volume of the solid that we get when we revolve the region bounded by the graphs of y equals root x, y equals 0, and x equals 4 about the x-axis. So just to get a decent picture, here's the graph of y equals root x. Here is the line, the x-axis is y equals 0, and here's the line x equals 4. So we're taking this space and rotating it about the x-axis. And when we do that, we get something that maybe looks like a bullet, maybe something that looks roughly like that, where our axis of rotation is going right through the middle. And hopefully this picture you can see that we have circles starting on the right end of the object whose radius is shrinking as we move to the left, but yet it's still a stack of circles. So the important points to notice is that our circles are perpendicular to the axis of rotation. And so that is a good key for when you would want to consider, that's when you would want to consider the disk method. And if they're not perpendicular, then you either need to find inverses or consider another method. So, the setup for something like this, we know we're going to have an integral, and we're going to want an expression for the area of all of those circles. And it's going to be in terms of x, because our circles are stacked horizontally, is how I think about it. So that means my line of circles from left to right goes from 0 to 4 on the x-axis. And now I just need an expression for the radius. I'm going to move this constant pi out front, and I'll square that expression, and then I'll have my integral. Now notice that the radius of all of our circles goes from our curve, root x, down to the x-axis. That's the radius. So an expression for the radius of this circle is always, for every value of x, the square root of x. So our integral, to find the volume, is the integral pi times the integral from 0 to 4 of root x squared dx. Now if we clean this up, when you square the radius, in this case, I'll end up with x dx. And when you integrate x dx, we end up with 1/2 x squared from 0 to 4. And that is equal to pi times the upper limit of integration squared, so 4 squared is 16, times 1/2 is 8, minus what we get from the lower limit of integration, which is 0, and we end up with a volume of 8 pi. This would be units cubed because it's a volume. So we identified how our circles were stacked, the way we were thinking about them. We came up with an expression for the radius and then integrated pi r squared.